My third lecture is on the D'Alembert's ratio test. Statement of D'Alembert's ratio test. If sigma un is a positive term series such that limit as n tends to infinity un plus 1 divided by un is equal to k, so that is we are going to take the ratio of the n plus 1 term and the nth term. Then how do you check whether the given series is convergent? The series sigma un is convergent if the value of k is less than 1. The series sigma un is divergent if k is greater than 1. What if the value of k is equal to 1? So if the value of k is equal to 1, we say that the D'Alembert's ratio test fails. And then we go back to those simple tests, whether it's a geometric series test or P series test or Cauchy's fundamental test. So whichever test is possible, if at all the value of k is 1. Now we take the first example. Test for convergence. 1 square by 2. That's the first term. I have mentioned it in red. 1, 2, 3 in this red is the term number. The second term is 2 raised to 2 divided by 2 raised to 2. Third term is 3 raised to 2 divided by 2 raised to 3. Fourth term is 4 raised to 2 divided by 2 raised to 4. So we can see the numerator, the terms are 1 square, 2 square, 3 square, 4 square. So the n term in the numerator is n square. Denominator has 2 or 2 raised to 1, 2 square, 2 raised to 3, 2 raised to 4. So the nth term is going to be 2 raised to n. So we start by writing the summation positive term series sigma un, which will be equal to sigma n square divided by 2 raised to n for n equal to 1 to infinity. So we write down the nth term of this. Un will be equal to n square divided by 2 raised to n. As soon as you write down the nth term, the next step is you have to write down the n plus 1 term. N plus 1 term will be simply replacing n by n plus 1 in that un. So we can write it as un plus 1. This is equal to n is replaced by n plus 1. It becomes n plus 1 square. And denominator, on replacing n by n plus 1, it becomes 2 raised to n plus 1. After we write this, we consider the ratio un plus 1 divided by un. So on simplifying that, I've just substituted it. Un plus 1 is n plus 1 square divided by 2 raised to n plus 1. And then I have taken the reciprocal of un, which will be into 2 raised to n by n square. Okay, so now since we are going to take the limit as n tends to infinity after the simplification, again we go for the same way of simplifying, that is expressing the terms as 1 by n form. So for that, what do? We simplify the terms and try to put the terms as 1 by n. So n plus 1 square, how do you simplify it? N plus 1 square, if you take n common, outside it comes as n square, and inside the bracket it is 1 plus 1 by n whole square. Denominator 2 raised to n plus 1 is written as 2 raised to n into 2. And the next part we already have it is as 2 raised to n divided by n square. And the terms which are cancelled, you can see there, n square gets cancelled, 2 raised to n gets cancelled. And when we apply the limit, we can see wherever there is 1 by n, that term becomes 0. And simplify this, the limit as n tends to infinity of un plus 1 divided by un, what will that give you? The limit value is 1 by 2. Now the comparison again is with 1, so this is less than 1. Then as per D'Alembert's ratio test, what do we say? Sigma un converges by D'Alembert's ratio test. The second example, test for convergence. 1 factorial into 2 by 1 plus 2 factorial into 4 by 4. The third term is 3 factorial into 8 by 27 plus and so on. So numerator you can see, first we'll check the factorial terms. 1 factorial, 2 factorial, 3 factorial, 4 factorial. So the n term is going to have n factorial. The next term in the numerator is 2, 4, 8, 16. And when we go for that, in the nth term of that is going to be 2 raised to n. You can just verify and see. For the first term, for n equal to 1 it is 2. For n equal to 2, the second term is 4. For n equal to 3, the third term in the numerator is 8, and so on. So this is the numerator. Now in the denominator, how are you going to write it? The denominator is 1, 4, 27, 256 and so on. So it's the same thing as 1 in the denominator of the first term. 4 can be written as 2 square. 27 can be written as 3 cubed. 256 is written as 4 raised to 4. So the n term is going to be n raised to n. So carefully when you practice this, you'll be able to get this n term to write down. Okay, so we write down un. Un is n factorial into 2 raised to n divided by n raised to n. Now since we have to go for the D'Alembert's ratio test, we are going to replace n by n plus 1. So it's going to be n plus 1 factorial. 2 raised to n becomes 2 raised to n plus 1. N raised to n becomes n plus 1 raised to n plus 1. Now here, how do we know we have to go for this D'Alembert's ratio test? If you just look at un, you can understand that we cannot simplify it in order to extract Vn from there to go for the comparison test. So this example, you can see un, from there you cannot extract Vn. So when those comparison test fails, the first test what comes to your mind should be D'Alembert's ratio test. So for D'Alembert's ratio test, after un, we have to write down the n plus 1 term. Right, now we go for the ratio un plus 1 divided by un. Now the same thing, un plus 1 is n plus 1 factorial. N plus 1 factorial can be written as n plus 1 into n factorial. That's the simplification what I have shown here. 2 raised to n plus 1 is written as 2 raised to n into 2. Then denominator is n plus 1 raised to n plus 1. It is written as n plus 1 into n plus 1 raised to n. Into, I have taken the reciprocal of un. Un becomes n raised to n divided by n factorial into 2 raised to n. So terms which are to be cancelled, I have shown it here. So what remains is only these terms, 2 divided by n plus 1 raised to n into n raised to n. Now again further you can simplify that n denominator n plus 1 raised to n. Take n common, so it comes as n raised to n into 1 plus 1 by n raised to n. That gets cancelled. Okay, so what do you get here? Limit as n tends to infinity, un plus 1 divided by un will be what now? Numerator has this value 2. Denominator has 1 plus 1 by n raised to n. And limit of 1 plus 1 by n raised to n is e as n tends to infinity. This is a known standard result which I have already come across earlier in your lower studies. So 1 plus 1 by n raised to n is e as n tends to infinity. So this answer becomes 2 by e, and the comparison at 1 is, this is less than 1. So as per D'Alembert's ratio test, sigma un converges. Now you can try in the same line these next 2 examples and check whether they are convergent or divergent.